Welcome back, those who were with us for the April kickoff edition of Space Data Hackers. And welcome for those of you who are new. My name is Mike Doyle. I am Director of Space App Seattle, and Space Data Hackers is our monthly meetup to get together the community of people who love space and data and want to connect with each other, learn more about it, and do great things with it. Okay, so yeah, it's May 27th, and this is our May edition, and I'll just go through some updates and maybe a few icebreaker questions to get us started off. Our theme tonight is show and tell, showing something that you've worked on, talking about something that you'd like to work on. You know, you don't have to come prepared with something, but this is a great place to, you know, show off what you've done, express your dreams. We've got Michael Patrick on the call right now, who has been a Space Apps participant for all of the years that I've been at Space App Seattle, who tell a little bit about some of the stuff that he's been working on. And Abhi Banerjee, who has also been a Space Apps hacker with a project that actually went to the you know, finals of the global judging round a few years ago, is meant to also join us and talk a little bit about what he's done and been up to. And it's also open for all of you. So we want to hear what you guys are interested in, what you've been doing, what you'd like to do. We've got time at the end of kind of like the material from Abhi and Michael to do community connecting. That's an important part of what we do each time, to get to know each other and think big. So some updates. Whoops. If you haven't seen it, there's a topic survey out there. We've got some responses in. I'd like to get everybody on this call to go out and fill in the survey. It will take you only a minute or two. It's not a lot of questions. Just so that we know, you know, what kind of way to steer the topics that we're covering. You know, so we can line up speakers. We can get the right folks in the room to help with learning, help with connecting. Joining the Slack. We've got a Slack channel. Just go out there and join it. I really recommend that because that's where we'll be posting a lot of chatter. And I think that's a mechanism that we can really bring the community to life. We set up a wiki, and thanks to Joe who contributed to that, and James for getting that set up. It's out there in a collection of useful links for getting started with space data, datasets, tools, and it's a place that we can just add on to it as we go along. The GitHub can also be a place where people can put their projects as they collaborate within the community. And you can join the Slack and request access to it with your GitHub account. We've got several social media outlets, Twitter, Facebook, and a Facebook group, and a website that is just very simple, very desperate hacker right now, but is someplace that you'll find easy to remember if you can't remember how to get to all of our good stuff, spacedatahackers.com. Okay. So I think we've got a good number of new folks on the line. I know that we've got, you know, the community connecting on the back end of our session. So if you are, you know, I won't make everybody introduce themselves to everyone. That'll take all night. But if you'd like to introduce yourself to the community, just, you know, jump in right now.
Hello, everybody. I'm Akopit. I'm really excited about this. I've met James before and work with Joe often too in our Python meetup. So I'm learning Python. For a living, I work as a Scrum Master in Meetup, but I'm learning Python right now, and I love space. So I'm trying to put two and two together. An idea which came to me the other day was I was reviewing a video on transit method and how to find exoplanets. So I'm going to try to find exoplanets using transit method using Python. There is some data out there NASA has published, so I want to try to do that.
Oh my gosh.
Thanks.
Alcaped, you are talking exactly about the things that I'm interested in. I've been looking at what can be done with exoplanet data as well. So we should connect.
Yeah, we should. I was actually thinking if we could find patterns in the transit method data and maybe even find satellites, not just planets. That'd be even further step, I guess. I don't know.
You just want to name a planet after your daughter.
Yes.
Actually, I just had a son. I had a twin, and I named him after a planet.
Awesome.
Sorry, I'll step out of my soapbox.
Anyone else?
Sure. My name is Patrick Selby. I run the Big Data, Deep Data Portland, Maine meetup group. And for the past about a year and a half, we've been doing, big data and a lot of AI as well. And it comes to mind that there's a lot of interesting problems to be done with data and space. So that's why I'm here. And hopefully sometime in the near future, I'd love to do like a startup around that topic in particular, because it's very interesting.
And did I catch right? You're in or near Portland, Maine?
That's correct. Yeah, I'm in Portland, Maine. Yep.
Wow.
Yeah.
Thanks for spending your late evening with us.
Hey, if you guys are in the area, we got good lobster and good beer. So.
Oh yes.
Thanks for having me.
Sure. Anyone else?
I just wanted to say hello. My name is Crystal. I'm a recent neuroscience and software engineering grad, and I'm just here tonight to pursue my interests and learn some more about this group. I saw it on Eventbrite, and I wanted to see what you guys are about. So, yeah, thanks for having me.
Well, great. Thanks for joining us, Crystal. Any others? We can keep moving.
Yeah, I could go next. My name is Rahul. I actually don't have any background in space whatsoever, but it is kind of like I am pretty interested in the industry, and I want to kind of see what are some of the opportunities out there. One project that I've been kind of working on lately was actually uses space data because I am really into hiking. And one of my favorite things when I hike is to go like above the cloud layer. And what I want to know is just based on like satellite data, can I tell if there's like an inversion layer such that if I go, say, hike Mount Si or something, that I'll basically be above the clouds in the sun. Fun little project. Nice.
That could be very useful during the cloudier times of the year around here.
Exactly. It's kind of funny. I reviewed a data portal today of a new startup, and my gripe with them was that precise problem is clouds in images when people are doing their data selection. So I was looking at the tops of mountains poking through.
Yeah. I've actually kind of had some. So actually, one of the reasons that I joined this meetup was to kind of see, what expertise was out there about this sort of data, and in particular, like how to use like Modis and all the other satellite providers out there. Yeah.
Nice. Well, welcome.
Thanks. Sorry, I missed the icebreaker questions. I don't know if that was.
Oh no, I got them inverted. So I'll hit up the icebreaker questions unless anybody else wants to say hey, introduce themselves.
Sure,
Yeah,
I'll
sure.
introduce myself.
Oh, go ahead, Doug.
Okay.
Sorry, I didn't mean to step on you.
No,
Anyway, real quick, yeah, my name's Doug. I'm a data scientist. I use Python. I haven't actually done anything with space data, but astronomy and astrophysics is just something that interests me. I read a lot of articles about that sort of thing. And so, yeah, I saw you guys on Eventbrite and thought I'd check it out.
Super.
great. Hey, everyone. I'm Ben. I actually am coming at this group from more of I'd say a business background. So I'm actually a current MBA, spent time in kind of investing finance world before. But I'm out in Seattle this summer, working at a space or at Blue Origin for the summer. So love space, love data, would love to find business applications that kind of meet in the middle of those two.
Perfect. Yep, that's part of our hopes around this meetup is to get folks like you coming together, finding business opportunities, and making value out of space data, or just doing great things with it. Okay. Anyone else? All right. Icebreaker question number 1. What's your favorite space-related TV show? Doesn't have to be fiction, and it doesn't have to be The Expanse. I'm giving away my answer right now. You can bang it into the chat. Yeah, well, my answer is The Expanse. Strangely, I can't see the chat while I've got my screen sharing on. Didn't realize that was a thing.
Your toolbar might be on your second monitor, Mike.
Oh, okay.
See it?
I do not.
That's a setting in Zoom. You might have it turned off when you're presenting.
Well, you're really
Okay.
missing out, Mike. You better get on there fast.
So we got a couple people really like Lost in Space, several for Battlestar Galactica, Star Trek, of course, Futurama, Babylon 5. That would be my second choice after The Expanse. Babylon 5. That was a classic. Yeah.
Great. Now, second question. I mentioned, we've got a couple people who can talk about projects that they've done. Anybody besides Michael currently on the call want to talk about a project that they've done or want to do perhaps in a little bit more detail? Sounds like there's a couple people who have projects that they're interested in.
So
Okay.
I posted something in the chat. This is Joe Devlin,
Hey.
and then I realized you couldn't see the chat.
Sorry about that.
So I did put together just some ideas since the last meeting, because I didn't know anything. I started out at 0, just and had to do a bunch of research, and that's where the posts in the wiki came from. But then I also tried some other things. So, but I think I should go after the other presenters so that we
Sure.
get, yeah, because it's just a mini discussion.
Yep. Sounds good. So yeah, let's do our show and tell. Michael, do you want to kick us off? If there's something that you'd
Sure.
like to share, I
How
can give you
long
control
should
of the screen.
how long should I ramble on? If you can give me a.
I think, yeah, I know you can go forever. How about we talk for like the next 15, 20 minutes, if that's what you think you'd like to cover.
So I just want to note, I got an email on a hackathon coming up here June 23rd and 29th.
Oh, nice.
Ask ESA, so I just thought I'd bring that to people's attention. And then I had a piece of NASA inspiration. About a month ago, I participated in the National Security Innovation Network. They're a DoD effort to solve specific problems and around wildfires. And one of the things that was really a problem with these events is wind data and weather data. It is just not at a sufficiently fine resolution and frequent enough for them to do the fire propagation. And so they were talking about their weather balloons and all the other things that they try to use. And I'm sitting there watching Ingenuity make its first leap. And then I said, you know, what you could do is you could basically have a drone radio sound with a inertial sensor in it. Its job is just to go straight up and then fly itself back to wherever it was launched from. But by using, if you just keep it oriented directly straight up, the wind motion velocity and characteristics should be measurable as far as what little math I've done. And so that would be huge. They could launch them as frequently and as close together as needed. So if anybody's got, you know, some money they'd like to throw, or if you're a drone expert or whatever, I think that would be a great leap forward to saving some lives. So I've been dabbling with doing Martian GIS, and the area we'll be looking at here is the Cydonia region of Mars. But in a more general sense, one of the barriers with people showing up at the NASA Space Hackathon is getting to the data. And NASA has such an immense amount of data. And one of the traditional ones is the planetary data system. But as you can see from the list of items on the left, if you don't know ahead of time what you're looking for, and then this one here just basically shows you a strip, like that's going to tell me anything when I'm shopping for an image from the area. And then they have various other nodes, like the one for Pluto's a bit better. In other words, it shows you the image and then it maps the white line. The white arc is the footprint that the image has on the planet. And it's got a pretty cool interface. This is a flyby, so you can just hit each image and it refreshes, so you can go through the entire sequence. So this was simple, but really cool. But I ran across JMARS, and this is put out by the University of Arizona, and it's a Java application you can run on your desktop. It installs flawlessly, and it's a GIS system, albeit a primitive one, but you can put up your own shape files and explore for data and do some analysis. And it's actually got quite a bit about every piece, as far as I can tell, of Martian imagery that was ever taken is in this. And so if we go to the next, basically I put up an area of interest, that red rectangle there, and the blue lines, I hope they're visible through Zoom, are all of the various image footprints. And then it will give you a preview of any particular. You select on either the rectangle or the image number so that you can hone in on what images cover your area of interest. Then you can, as you do your work, you can save the session so you can build your own model of an area. And so a lot of the other science package details and sensors are also in there. And you can do the standard measurements and things like that. So I thought this was fairly accessible for a new person. And so this is Esri ArcGIS. I also use QGIS, the open source GIS package. And these are NASA data sets and a couple of my own. This is the overall cartography, the standard cartography of Mars. Those rectangles they've come up with standard map sheets, so to speak, like USGS ortho quads, so they can, reference those. And one of the data sets I was using was the Mars orbiting laser altimeter. And so you can using JMars, you can download these data sets and put them into a desktop GIS system and start beginning analysis. And one of the things I do is geomorphology. And so I do automated feature extraction from digital elevation maps and things like that. So I was pretty excited about this because and there's other terrain analysis tools out there. And so, for instance, at the bottom there is a color-coded elevation map. The middle is actually how open the terrain is. So if you were concerned about communications, for instance, between Ingenuity and the rover, that would tell, the red would be places you don't want to be, and blue is the places where you would want to be flying over so that you would maintain your communication link. And then the top one is actually a 3D representation of the terrain in that area. But what's cool about JMars is it isn't only Mars, it has the imagery links to other bodies in the planet. So I'm going to explore a little bit more with this. To me, JMars seems to be an easy entry for somebody that's just starting out with the finding the data and things like that. And I know people have been very frustrated in the past. So if people want to do these city building exercises or making 3D models of Martian terrain or whatever, this would probably get them to a point of happiness faster than trying to use the planetary data system network. And so if it is still working, so how do I switch there we go. So
you still see your PowerPoint. So if you wanted to switch to a different app, you're gonna have to stop sharing and reshare that app.
Okay, which showing?
Now we see your arc scene.
Okay. So that's the digital elevation map from JMars in my area of interest. That's the shaded elevation map. That's the imagery. And And then this is the relief visualization. So let me, whiteboard. I see it on my toolbar, so I know it exists. Oh, here we go. And this is always the hazard with doing any sort of live demo. So, and the reason I'm doing this is just to give you an idea of how good the MRO imagery is. So if we get down here at the pixel level, and we do a measurement, I'm measuring 1 pixel, that's 0.5 meters. The surface of Mars is mapped better than the surface of the Earth. And that is not even the highest resolution data that they have out there. The data they have for the lander sites is actually even much better than that. So that is basically let's see. So that's a GIS system with the data, and then JMars itself. So is JMars showing up?
Yes, we can see JMars.
So did the other windows show up? The sub window?
Only seeing one window.
Okay. So unfortunately, these are child windows of the Java application, but one's a 3D map. I will take a quick screenshot and we'll move along. So I can post the file in the chat channel. So basically you can go anywhere on Mars and select the different data sets that are available for any given region that you're interested in. And of course, it's going to be pretty pokey trying to talk through Zoom. So, but I'll leave it at that for right now. Are there any questions?
There seemed to be a lot of clustering of data sets on the map that you just showed. What does that correspond to? Are those lander sites or?
Oh no, actually, there's a group of, let's say, call them enthusiasts, that when they discovered the face on Mars are kind of locked into the idea that there's an ancient civilization on Mars. And I was in an extended conversation with them, and I always try to keep an open mind because they'd make statements, and of course I reflexively, being overly intellectual and egotistical and a megalomaniac, I immediately think I know better, right? And so I catch myself and I go, well, really, do I? I mean, what's my best available evidence? And so I use the dialogue with them as an exercise to see how far down I could drill with Martian data from the different platforms and stuff, to also to explain. I mean, I might have a tendency to make fun of them, but you know, there have been a lot of very competent scientists that have, you know, and collectively as a society, we've gone down the merry road of certain beliefs, etc. So I used it as an opportunity to test their hypothesis and dust off some math tools to see if their, you know, their claims could be proven or disproven mathematically. So those points there are the city on Mars, and their claim was the mathematical relationships between the objects, so that certain distances and angles were represented in that collection of points. And so I went down, I took a LiDAR data set of the Mimas Mounds, which are south of Olympia. And it's these mysterious, they're in Washington State here. They're kind of a weird artifact. They're about 6 feet high, 12 feet wide. And they're essentially a very large area of random mounds. And I did analytics on it and discovered that in a random collection of similarly sized mounds, you will get a 45-degree, 60-degree, 45-degree will actually predominate. And for a very good reason. Most of the tiling that occurs in the universe is for this very same reason. You can look at the top of Saturn and you can see a large hexagon there, right? Yeah, it's caused by the equilibrium points, the dynamics of the atmosphere. So that's what those points are.
Patrick, I'm kind of interested. So you talked about geomorphology, and you also talked about measuring distances on Martian surface. So can you tell me a little bit, like, I'm just interested to know, like, what kind of projection system they're using, these data sets or data?
I could give it to you. I can't, I deal with about 100 projection systems a week, but let me look here. It's there's basically been only two, unlike the Earth, where there's been several thousand, there's several tens of thousands. Sinusoidal Mars, I don't have the EPSG number.
That's fine. I'll just write it down.
But do you have my email?
No. No, I can take it later during the.
You guys should both get into the Slack and chat in the Slack.
Yeah. Thank you.
What is the Slack link?
Sure. Let me just bang that into the chat here so that everybody can click on it.
Great.
Sorry, I meant to do that.
Also,
I thought Pranav was going to ask me a tough question, like what was the projection system used on one of those asteroids, which has 2 lobes? You know? Those are much more interesting.
So just for those who were not with us in April, Pranav was our speaker for our launch event. So Patrick, I think you had a question.
I just had a comment regarding the drones in the beginning there. Just today we had a fire on our island, and the firemen needed to come back and monitor the surrounding woods once every hour to check for embers and smolders to make sure nothing flared up. So it made me think of, you know, having a drone and some kind of temperature sensor to kind of check for that area. That would definitely be really relevant, seeing that we just had that fire today.
Yeah.
On the same vein of the wildfires, I'm also thinking if maybe insurance companies would pay for the drone system because it will give them some useful data.
They could do a risk model based on collecting that data. Yeah.
So the part of the difficulty is, with the drones, is the most dangerous part of the fire is the early spread, and being able to have one in place, et cetera, to catch it when it's early on is just continually problematic. I'm talking with a scientist. He is advocating putting up a satellite in geostationary orbit, which can actually is designed for the wavelengths that wildfires exist, at, because the other difficulty is they put out so much heat that they flood ordinary sensors. So even infrared sensors to a large degree get flooded. So your imagery sometimes ends up being useless.
What's like the average latency that that you'd get from just like, one of the traditional like Earth observation constellations, like not in geostationary orbit, but in like, lower orbit? Like what's sort of like lag time you could expect from using one of those?
The best right now is twice, if I recall, is twice a day. Now, if there's a constellation, that, depending on where the satellites are in the constellation at a given time, that could be a matter of minutes or hours. But the most commonly used or ubiquitous platform is about a 2-day refresh, or a twice-a-day refresh.
Just a quick comment. My understanding is that there is some satellites already pointing back geostationary back to the US, looking for radiation for, if there's a nuclear incident or something.
Those are the defense monitoring satellites, and they're looking for lots of, well, the new ones, the new constellation can detect a Scud missile exhaust. So in all probability, they could detect a.
Interesting.
So I don't assume that anyone here has the power to make this happen, but like with the Starlink constellation going up, there should be like one overhead in like low Earth orbit at any time, right?
As a Starlink user, I can attest to that. That's mostly true. 30-second gaps occasionally, in my experience. But during the daytime, very, very good coverage.
Goal for that is when they finish it, there'll be 2 or 3 at any time overhead.
Yeah.
The issue there, I think, with imagery is your optical train and sensors and stuff. There's a certain amount of minimal packaging that's in power that's required, as opposed to a relay type of satellite. And so you could potentially put some kind of camera on it, and if you restricted it to like one frequency or one wavelength, maybe it's doable. If it reported back on the same data link. That's an interesting question.
I've been looking into these things called hyperspectral cameras recently, and I don't know if you guys are familiar with that, but they're quite fascinating, where they'll take the entire spectrum, visible spectrum, ultra and infrared, and then combine it into an image. It seems like a very, very promising technology.
It is. You can tell the difference between brands of roof tar. And
Can you really?
Yeah, they publish these spectral libraries, not so much from spacecraft, but from aircraft like the U-2, etc. There's and business Gulfstream sized jets, and they are very informative. You can gather a lot of information. One of my continual frustrations is people are trying to do things with machine learning to, you know, figure out what something is on the surface of the earth. But if you just look in the infrared, it's really, really obvious what something, you know, something is.
Sure.
Or if you use radar, people need to think more out of the visible range.
Yeah. I think the problem is that neural nets have become the solution for everything. And sometimes people don't question, you know, what they're trying to discover. So, you know. Interesting.
Cool. Any other questions?
Well, thank you all.
Thank you, Michael.
Thank you, Michael.
Thank you. They're super interesting.
We want to move on to Joe.
So I'm going to do something risky. I've got the audio on one computer and the screen share on another.
What could go wrong, Joe?
Just everything.
It's just technology.
I'm going to share the whole screen. And switch that so you're not looking at, we won't be looking at ourselves, looking at ourselves. So I made some notes about my experience since the last meeting. And the first thing that I did was I went back and looked at the Space Apps projects from 2012 to 2020. And I found out that 2012 is now behind a paywall. And the data from 2013 is just not that good. And so I just started with 2014. And it turns out, and I put these links on the wiki, but I thought I'd try doing a Google search. So for example, here's some keywords. And this is a custom Google search only on these pages. And so if you do something like data, because that's one of the keywords, it gives us a bunch of ads. But then below that, it picks up the years and not in any particular order. But then it doesn't really drill down into any of the data. It's just very flat. And you know, it's a start anyway, but it doesn't really, if you were searching for something specific, it wouldn't find it. And so I thought, well, okay, I'll try Watson Discovery. And so I fed all of these links into Watson Discovery, and it returns lots of data. But the problem that I ran into with that, and which I was happy that there was lots of data, but it kind of lost it grabbed the HTML, and it'll allow me to serve the HTML, but it loses the upper links. So I haven't figured out how to find out where this data came from. Anyway, so that's my challenge there. I'll have to keep working on that. It lost the top domain links. And then I thought, well, okay, I'll just go through and look at every one of these years and put everything in a spreadsheet and, you know, read every project. And that really didn't last very long. I got tired of that. I did the first year, and then the second year, each year there's more data because there were more participants. And so, but it was fairly accurate because I could get exactly what I wanted out of it. And so then I was thinking back to the discussion about searching for data, and I found a project called from 2015 called Space Tag, and they have a good YouTube video that a 1 minute video. Each project has a 1 minute video, and so you can see what their project looked like when it was running. And I thought, well, okay, I'll take you guys up on the challenge. What would it take to resurrect one of these projects? And so, see if pretty small, isn't it? If I do that, it makes it a little bigger. Is that more visible?
Nice.
Yes.
Okay. And I sort of got it running to the point where the web page was up, but then I found some things that, for example, if we try to do a search, it goes out and looks for a database, and the database is gone. And so I tried connecting a database, and I'm still at the point where I don't have my magic secrets connected here.
Can you grab from the cache, like do a search on Google for the cache version of a website and pull that?
I don't. That's a good idea. I'll have to look at that and see if they had a live website. Do you want me to do that right now while we're talking about it?
No, keep going. No.
Oh, okay.
There's also a site called archive.org, Joe, that does that
Yes.
as well. I use that a lot when I'm looking for stuff that's not online anymore.
I think that's the same as the Wayback Machine, is it not?
Yes, it
Yes.
is.
Okay. Yeah.
So what this is, if you look in the video, you'll see that it was a graph of the data and an interactive graph. So you could click on one of the nodes and it would give you the information about that node. And then you could drill into the node and it would find more data within. So it wasn't, even though you could go to the website, you wouldn't get the interactive part. But I may still be able to get it working. But what I did find, and this is a question for you guys, right here, that if you put that into your browser, at least in my browser, it just ran forever, and then eventually the browser quit working. And so the source for their data is even, it appears to be gone. So I have some searching to do. So the point is, if you go back too far on some of these projects, there's deprecated syntax, there's unmaintained dependencies, security issues. There's hard-coded databases that have disappeared, and even the links to the NASA databases have changed. So it's kind of hard to go and that was 2015, so it was pretty far back.
So I'll bet you if you go even to the hackathon that happened in October, you might find a good number of these issues as well. It's kind of the nature of hackathons. You get a bunch of people to slam something together over a weekend. It can be great, but it is exactly what it is. It's, people putting something together over the weekend as quickly as they can to demonstrate value. The thing that, what we as Space App Seattle are hoping to solve for is, well, how do you really derive even more value out of those initial hits of inspiration, right? So that you've got projects that have legs that go on to have a bigger life and a longer lasting impact. It's really, really hilarious to me that you hit on NY Space Tag as a project to deep dive on. That came out of Space Apps NYC in 2015. That was my first Space Apps hackathon. And I saw those guys stand up and present it. And then
That's really cool.
Yeah. Oh, and you know what? I keep talking about Space Apps Seattle, Space Apps NYC, or Space Apps Hackathon. Just for new joiners who might not be familiar with what we're talking about, NASA has a hackathon every year, and it's happening in October this year. Space Apps Seattle is the organization that organizes the hackathon for Seattle, but it also happens around the world. It's one of the world's largest, if not the largest hackathon. And you know, there's tens of thousands of people, hundreds of countries and location sites. And Joe is starting up a Space Apps Tacoma this year, and really excited about growing the Space Apps footprint in the Pacific Northwest. So I can tell you, going to the Space Apps Hackathon in 2015 was a life-changing event for me. And I had a total blast, went back, you know, as a hacker for 2 more years, and then became an organizer after that. But as a result of the continued engagement with Space Apps, I actually went down to NASA headquarters at one point with my daughter, kind of on the back of a project that she was doing, and learned that NY Space Tag was actually incorporated into the IT infrastructure at NASA. They took the basics, they worked with the team, and then they expanded it. And it is now how NASA tags their data. The problem in that was shown at the hackathon was that there was no standard convention, no way of tagging. Humans were tagging it, right? And humans don't always tag correctly. If you looked at how NASA data is tagged, you would have thought that it was an extension of the Department of Agriculture. Agriculture is the #1 tag on all the data sets.
Right.
And so NY Space Tag actually addressed that problem and got incorporated into something actually at NASA. I don't know of many hackathon projects that do actually have that. You know, there's
The cachet.
Sorry?
The cachet of saying that they got incorporated into NASA. The cool factor.
Yeah. Well, there's definitely a cool factor. There's definitely a cool factor of hacking NASA challenges at the hackathon. But to actually have NASA use your tech is pretty rare. A lot of projects are great ideas. They're great things that come about that weekend. And like I said, some of them have legs. This one did, right? This one kind of like went the distance to becoming, you know, a really viable product. But the project itself is kind of, you know, a little bit of a fossil from that time. So that's my little bit on NY Space Tag.
Just a quick comment too, since then, I think GitHub has become a bigger player as well, as far as keeping the longevity of projects around set up, and then new people can come and pick it up later on and find the files and all of that.
Absolutely.
Yeah.
So it wasn't just random. I read, I don't know, probably 100 different projects and listened to the videos. And this is, I think they say somewhere that maybe in the footnote or somewhere that their project got incorporated. And so I was curious to, you know, just to see it working. And anyway.
Well, I guess just a follow-up question. Have you seen NASA embrace GitHub as well, or do they not because they're kind of a public-private organization?
So let me switch to the, do I have the wiki up? I thought I would have it up. Yeah, I don't. If I click here. Right there, is that what you're talking about?
NASA's GitHub.
GitHub.com/NASA.
Yeah, that looks like it. Yeah. Oh, I didn't know
So
they had that.
They have 351 repositories.
Oh.
And I haven't really looked through that, so I can't.
It's probably
say
just relatively new, though. Relatively new projects in the last couple of years, I would imagine.
Well, I know that NASA is using it indirectly. There was a really interesting talk, I think 2 months back, that New Tech Seattle put on with a representative from NASA's Open Innovation Office, and talked about how NASA is crowdsourcing a lot of solutions, kind of like saying, you know, we need this kind of algorithm and putting it out on topcoder.com and getting people to compete for the best solution, saves cost, massively opens up the talent pool that can address a problem. They even had an example where they did it internally. And James, I don't know if you remember the exact technology in question, but the team that put out "we need this" was surprised to discover that somebody was already working on that, just, you know, like just a few hundred feet away, in the same building.
But left hand doesn't know what the right hand is doing there, right?
Get a lot of people innovating fast. Large
So
organizations.
a project that received, I think, a badge for that was the software that's running the helicopter. Is that what they're calling it on Mars? So the software that ran that helicopter was basically open sourced. So anybody that worked on that project somehow got a little bit of credit for that.
Yeah, GitHub put out a badge for any contributor to any software that was used by the helicopter, including all of the dependencies. So it affected, I think, over 1,000 projects on GitHub. And everyone who was ever a contributor to those got a special badge on their user profile on GitHub that said that they contributed to the Mars helicopter.
Wow.
Very cool.
Yeah, that's super cool.
Well, if it's okay, I'll finish the last items here and then close up so that we can listen to somebody else. Because, go ahead.
So Joe, I do mostly in the past natural language processing too, and if that is an area of interest for you, data discovery, not just at NASA, but across all data portals, is still a huge, huge issue. So I thank you for working on this. This is really on point and a good effort.
Based on your comments from last week, that's what gave me the idea to take a look at it. So I'll if I have questions, I'll post them in the Slack. And then part of the problem is I don't even know what questions to ask, but you know, every time I come up against a problem, then you know then I have the question. So and as Michael somebody pointed out, that I'm running I have the idea to based on what you guys have presented, to try to promote here in Tacoma, mostly because people will relate on a local basis. And I put a promotion letter in the Slack, generic. And if anybody wants to give me feedback on, if it's too corny or too specific or whatever, and then I put some of my notes in a public OneNote also posted in the Slack. And that's all that I have for sharing.
Well, cool.
Yeah, thank you, Joe. That was great.
Yeah, thanks, Joe.
So does anyone else have anything that they would like to share? Any ideas of projects that you'd like to do? Maybe not something that you've done, but something that you're wishing for.
If nobody else is going to pitch in, well, I'll share it. But in the past, I've had heart trouble, and now I'm feeling pretty good. But when it got smoky outside, I could go outside, and within an instant, I'd think, man, I am not going to stay out here. I'm going to go back inside because it would be too smoky. So air quality is something that I think about a lot. And so that's air quality is, if you're talking about projects, that's something that I don't know if satellite data can really help with that, but I know ground sensors help a lot. You can tell from ground sensors how, even in certain areas, somebody will light up and the ground sensors will start detecting right away. Anyway, that's my.
So there's quite a constellation since climate change is a big science initiative right now. And actually some of them are so new that I really I'm not very familiar with them, but basically they look at every droplet particulate that is in the air column, the atmospheric column beneath the satellite. And I'm not certain, some are really fine resolution. Basically they shoot a laser beam down, and as it goes through the different layers of the atmosphere and the different particles, when it comes back they can tell. It's kind of the same principle they use of aiming those giant telescopes and correcting for the atmospheric refraction that's going on. And then there's ones which are much larger, kilometers, square, etc., that measure the different characteristics, mostly by the amount of different wavelengths that get reflected back to the sensors. So there is data there.
Joe, you can definitely look at something called aerosol optical depth. That is basically in an air column, how much aerosol have, and what Michael was just saying, based on refraction of light. MODIS has that data. I think it's available daily or certain cycles.
Let me repeat that. So aerosol optical depth.
Yes, that's correct.
Okay, I'll take a look at that.
Sure.
But one thing that I realized here in Portland in the wintertime, the air quality seems to get much worse. And I think it's due to people running furnaces, and the furnace are powered by oil, and there's no filters or anything. So in the wintertime, it really seems like the air quality is worse. And I'm sure if you had the data to back it up, you could see that.
Actually, there is, and that is why, and there's a lot of similarities between Seattle and, this is Portland, Maine, right?
That's right.
But there's still a lot of similarities. But it's wood smoke. So do people still use wood stoves in Portland?
Yeah, absolutely. A lot of
Yeah,
wood, a lot of oil, you know.
that's the big culprit.
Mhm.
The modern gas furnaces and even the older oil furnaces, I'm not gonna say they burn super clean or whatever, but they're 100 times better than a wood stove or a pellet stove or whatever.
Sure. Yeah, I think the new stoves I've looked at too, they have like a little catalytic converter or something in there to help kind of burn things off. Yeah. But I think about that as as you go around, just when you're breathing, you're like, this air isn't nearly as clean as it is in the summertime.
Definitely true. And then the inversion layer also confines it close to the ground.
I know
Okay.
too, ground-based ozone, I guess, is occasionally a problem as well. And then I'm not really sure how that affects people, but if you do have a heart or lung condition, I think they're affected more than others.
Okay. I wanted to share my little dream about engaging with space data, because even though I hacked at the hackathon for 3 years, I think it was only my first project that was specifically data related. The next two were more about astronaut health. My daughter and I made an app for the Microsoft HoloLens that is powered by exercise. There's HoloLens on ISS. She wanted to make astronaut exercise fun. And so we did, and we had a lot of fun doing that. But last time we were in April, we were talking in the breakout rooms. I was kind of like, you know what? I would love to find an exoplanet, as I mentioned before. So I did a little bit of looking around. And I found that, yeah, there's actually citizen science projects that you can get involved with at NASA. They've got 3 that are related to the to TESS, which is the transit. Okay. Transiting exoplanet sensing satellite. I think that's it. But the it kind of ranges the gamut. So there's Planet Hunters, which is one of them, and you can examine light curves. There's Planet Patrol, where you're actually looking at the images that are taken to help categorize test candidate planets. The basic idea that was really interesting to me was that, we talk a lot about machine learning and artificial intelligence, and these projects are out there to use human brains, and lots of them, to fill in the gaps where the algorithms run out of steam. There's also Exoplanet Watch. If you've got a telescope of your own, you can also supplement the data. So that's not mine. I don't have a telescope or really the kind of cloud cover that's going to help out with that. But Planet Patrol or Planet Hunters will definitely be of interest once they have data. Again, it takes a couple of weeks for TESS to send back data, and then I guess it goes through scrubbing.
Well, I was just noticing, it's obvious to me that there's 2 planets in that data stream and 1 tidally locked moon.
Wow, you're good. The other thing that I saw was that there are lots of additional science, citizen science projects. So you could potentially backyard worlds search for Planet 9. you could potentially find a new planet right here in our own solar system, and then lots of other things to get involved with. So cool way for those who, like myself, don't have a data science background to do something with NASA data.
Very cool.
There's another project that was listed on that site which looked pretty cool about the landslide detection.
Yeah.
Yeah, that was actually an interesting one for me because you know, first of all, like, you know, landslides are a pretty big deal for property and life, and they're also like pretty hard to predict. So I'm kind of curious what they're doing about that. Guess it would be a lot of like tagging landslides that happened and trying to like predict like conditions that could cause them in the future.
I think there's some interesting sensor networks that they've been using to study the when there's an earthquake on one part of the world. You basically get a vibration that comes all the way through the earth, and then it bounces around the earth several times. So you can detect that same vibration in several different areas, but it sounds like a great machine learning problem right there, right? To detect that pattern on where you might detect the earthquake next. And the magnitude, right? It's really a question of magnitude.
Yeah, so I just posted the links to both what I was looking at and landslide. So it looks like they're asking you to take pictures of landslides to report them and help build a database.
So when I was, I don't know what this thing did here. So when I was in grad school, I did a landslide related project for Army Corps of Engineers, because landslides affect salmon habitat. You know, they fill the creeks with silt, which basically gets into where the eggs are and turns it to concrete. And so in the Pacific Northwest, we do a lot of logging and stuff, and we log a piece of ground, and it isn't like right afterwards. It's 7 to 15 years afterwards, the tree roots rot out. And then basically because of our clay and everything around here, the whole side of the hill just cuts loose because there's nothing knitting it together again. And it usually originates on a road cut. So that's a application of that geomorphology, is being able to take like a digital elevation map, extract these salient features like the road cut, the slope of the ground, and then using like spectral unmixing to determine the age of the vegetation. And you can get like a really amazing insight into how vulnerable areas are over a really wide area. So that's cool that they're working on that. So the USGS is releasing a 1 meter resolution digital elevation map for the whole country over the next couple of years. So that will be also a great opportunity for that landslide effort.